A concrete class is not allowed to contain any abstract methods at all. Remember though that because classes can inherit from other classes, and because there could be abstract classes in a parent class, you're going to inherit such abstract functions. Now, if you don't implement all of those abstract functions, then the subclass is going to wind up being abstract as well. So even if there are uh, methods in the parent that are abstract that you have no need to implement, you still need to implement them, because if you don't, you will wind up being an abstract class. So to summarize this, you can only be a you can only be a concrete class if you contain no abstract functions, inherited or otherwise. You need to implement everything that you've inherited that's abstract in order to be concrete. Even though you're not allowed to use the new operator with an abstract class, it's still possible to define constructors there, and they will be invoked as a side effect of invoking constructors of the subclasses. For example, the constructors that exist in geometric object will still be invoked in the circle and rectangle class implicitly as a result of creating circles and rectangles. So far from what you've learned, you may be left with the idea that if a class is abstract, it must have abstract functions. That's not necessarily true. In fact, what primarily makes a class abstract is in the declaration you say that it's an abstract class. It may in fact contain absolutely no abstract methods, and that's all right. It's still declared to be abstract, and therefore you still are unable to create any instances of that class using the new operator. In this case, the purpose of doing this would be to create a base class from which you intend on defining new subclasses, and you don't ever have an intent of providing or creating an object of the class itself. Another point that might not be obvious is that a subclass is able to be abstract even if its parent is not abstract, even if the parent is concrete. You might wonder how that is, but you need look no further than realizing that all objects inherit from the object class, and the object class is not an abstract class, it's a concrete class. So immediately you know that all objects that are abstract actually are still inheriting from a concrete class, namely the root class, which is the object class. Furthermore, you could have a concrete method in a superclass that you decide you're going to override and make it abstract. Although that's rare, it can be useful, and it's something that may be done. The reason for doing this could be that in the context of a subclass, it could be that some method in the superclass becomes unmeaningful or invalid. In such cases, then, the subclass has to be defined to be abstract. Once again, just to remind you, you are not able to use the new operator with an abstract class. However, despite that, you're still able to use an abstract class as a data type. This again makes the distinction between declared types and actual types. Now, prior to the material we're looking at right now, our geometric class used to be concrete. In this lecture, it's become abstract. Even though it's an abstract class, we're still able to declare an array of this abstract class. So in other words, we can declare geometric object array geo, and then we can say equals new geometric object 10. The reason we can do this is because we're not actually making new geometric objects, we're really making an array of references to geometric objects, and that is allowed.